Welcome to this lesson, Lesson 4 of Introduction to Solidity Programming and Introduction to Blockchain. This is a presentation of coding boot camps. So this is blockchain operation and mining. And we have covered this information, and we have also covered this information. To recap, in our previous lesson, we talked about hashing and how a blockchain is built using hashes. And we also talked about the blockchain types, private, public, and permission. A little bit about blockchain operation and mining. So once data is entered into the blockchain, the data is permanent. Written data is hashed and cannot be changed. Blockchain nodes must synchronize and reach consensus. So we talked about this a little earlier. If each of us had the same Word document or the same PowerPoint presentation and we all were working on it, adding and subtracting about the same type of information, but we would know that eventually each of our copies would drift slightly and be different. We all have a different copy. So the whole idea behind consensus is let's all figure out which one of these miners or which one of these users of this document or writers of this document has a copy that is all up to date and true, and we can all use it and send them one single copy to all users, and we all now have the exact same data and we're fully synchronized. So that is the idea behind consensus. So blockchain operations and procedures and terms, we have a nonce. So a nonce is a number used in cryptography, and it's only used once. The nonce is a random number and may include a timestamp. A nonce prevents repetitive patterns because it can only be used once, and if it's appended in part of the data, you can see how it can change data so to prevent repetition. Finding the block's nonce is a key requirement for adding a new block to the chain. And we can see here we request a nonce, a nonce is sent, and then the connection is made with a username, nonce, and a password. That includes a nonce and a password, and a token is received. And a Merkle tree. So a Merkle tree is a mathematical data structure. It's a tree structure made of hashes. So every leaf is labeled with the hash of its data block, and every non-leaf is labeled with the hash of labels of its child nodes. If you look back at the white paper written by Satoshi Nakamoto about Bitcoin, you can see he greatly refers to Merkle trees. Merkle trees are used for data verification when stored data is transferred between computers in a peer-to-peer network. So let's take a look here. So we can see here that the leaf is, in this case, I guess you could say is the top hash here, and how it is pointing back to hash 0. You can see hash 0 written there, and hash 1. And we can see here, it says hash 0.0 and hash 0.1, and you can see how these where these different hashes are actually pointing back to previous hashes. A block on a blockchain is a file. So just like any other text file, it's relatively simple, usually limited to about 1 megabyte for management purposes to prevent runaway blocks. A block can be thought of as a cell in a spreadsheet, like we discussed earlier, that contains transaction information, a timestamp, and a link to a previous block and other information. The block structure has 4 basic elements. So the block size, header, transaction counters, and it has transactions. So if you see here, we can look, this is the structure of a block. You see here the block size, the header, the transaction counter, and the transactions that are part of the block. Blockchain operating procedure. So a block height is just simply the number of blocks on a chain. And we will actually see, if you look at your blockchain explorers, you can see they're very clear what the current block height is for Bitcoin, for Ethereum. The block time is the time needed to generate a block. Uh, we're going to look at one special fork. Now, forks, you can see here, we talk about a fork and then a hard fork. Uh, in our case, a fork is going to be almost a temporary line off of a block where miners are working on their own and they're adding transactions in the hopes that they will be selected to add the actual block, the permanent block to the blockchain. So a fork is a temporary set of blocks. A hard fork is a split in the community. So that's where one part of the community moves in their own direction. So what they would do is at a certain point, take the existing, say in a case of blockchain, one new community says we're going to take this blockchain as it exists now, we're going to copy it over to our own set of developers, and we are going to take it in a different direction up until a certain point, and then they change direction. Mining is the process of keeping the whole blockchain up to date and organized. So again, miners verify groups of transactions in a block, and miners take part in consensus to keep the ledger synchronized. And miners validate transactions, and when transacting an asset, pending transactions are created. So if you and I would transact Bitcoin, initially when those transactions are complete, they're entered as pending transactions until verified by the miners. Miners receive a notice of these pending transactions and then work to verify them. And adding a new block involves verifying all of the transaction records in that block and then doing a computationally intensive process where the block's nonce is discovered and then the hash is added. So miners use this process to find the block's nonce. This is called proof of work. And the proof of work is very expensive. It involves a lot of calculation, uses a lot of electricity. So we can see here the completing the proof of work proves that the miner is contributing transaction validating, computing power, and electricity to the network. But it also can be quite expensive. At a certain level of processing on the blockchain, all activity stops. And then the data is broadcast across the network of the new block. If 51% of the nodes agree, they synchronize on that new block. The miner who found the nonce and added the block receives a reward, a certain reward of the blockchain's native token. So if it is Bitcoin, the miner that added this new block that everybody agrees is correct and valid will receive a certain amount of Bitcoin. Blockchain also for mining here, locating the nonce while running the proof of work involves no special skill set. The proof of work software uses random number generation to test for the nonce. It is no different than if you had a combination lock and you just went through trying different combinations. Let's take a look at a fork here. So what's happening here are these are the permanent blocks here, 1, 2, 3. So for block 4, though, we are looking to add block 4 as miners. So one miner will be looking at block 4A and be on this A trail or this A line. Another miner looking to add block 4 is on this 4B line, and we are validating the transactions, hoping to be the first one to find the nonce and to add block 4. So in this exercise, what would happen, just think this to yourself, what would happen if the ledgers in the nodes did not reach consensus? Would the blockchain be useful? Okay, well, think about that. And think about our examples before. If we all had a copy of the same Word document and had to add the same general information, how would we know which is the absolute correct document if 25 people were updating the same document with about the same data? Would they all be different? Most likely. Which one would be the most accurate? That's what we have to understand. And what would be useful if they were all different? And again, we talked about blockchain elements, the nonce, the Merkle tree, and the block itself, some block terms, block height, block time, and our blockchain mining procedures. Please go through the assessment and see your learning materials for the correct answers. And again, check your learning materials for these and other resources. Our next session, we're actually going to have our introduction to Ethereum. Thank you.